Hey guys, welcome back, and today we're going to be graphing proportional relationships. So that's exactly what our learning target is going to be, graph proportional relationships. Success criteria for this is first, I can plot points accurately. That might have you think back to our first unit when we did transformations. We need to be able to plot the x, then y first. Remember x comma y, go right and left first before we go up and down. We're also going to be creating these points too, so we need to be able to know which is x, which is y, as well as the second success criteria, I can determine which unknown is dependent on the other. In 7th grade, you probably learned about independent versus dependent variables. Independent variables are going to be the variables that you choose. Dependent variables are what comes out of what happened to it. So an equation or some sort of change is going to happen to your value, and the output is going to be the dependent. Whatever you input is going to be the independent. Lastly, I can create a table of values according to a situation. We're going to pick random values according to specific criteria, and we're going to create a table that we can graph. Alright, so let's get started with the first example. It says a video game store has a frequent shopper program. You earn 4 points for every video game you buy. Draw a graph to model the situation. You need 48 points for a free game. How many video games do you need to buy to have enough points for the free game? Now, before we get to this last question, which I know many of you guys may be able to figure out the answer to that question before you even do the graph. But the question is asking for you to construct a graph first. So let's keep that second paragraph in the back of our mind. Let's not try to answer that question right away, because a lot of times visual representations are what people are looking for. In your future job, you may need to make a presentation, and having a visual is going to help you be able to convince the people you're talking to. So let's create a visual of this situation. The way we're going to do that is we're going to create a table of randomly picked values. Now I say random, but you can pick these values to be as easy as you want them to be. So for instance, the whole idea here is I should see values where I get 4 points for every 1 game. So if I buy no games, let's call X the games. If I buy no games, I would get no points. So I'm going to label that as well. I'm calling X the games, and I'm calling Y the points. Now, can you switch those two things? Yes, but I feel this makes more sense because you buy games to earn points. The points depend on how many games you buy. X is always going to represent the independent variable. It doesn't rely on anything. But Y represents the dependent variable. It relies on whatever X is in order to get its value. So I want to think about X in this situation first because, again, in this real life situation, you're not going to get points unless you buy a game. But you can buy a game and not care about points. So here I have 0 games would get you 0 points. Well, if you bought 1 game, which is in the words themselves, here let me highlight that. That's the important information here, is 4 points for every video game you buy. 4 points per 1 game. That's what they're saying here. So I'm going to put that into the situation. 1 game, X meaning games, would mean 4 points. Now I'm going to maybe put 1 more point in my table. Anytime you're making a graph, you should always try to make as many points as possible. I'm going to do 1 more point, and then I'm going to talk about how I know where to put the rest of those points. Now I don't just want to go 0, 1, 2. I'm going to maybe guess something a little further away so that I can see kind of the shape to which these points are forming. So let's try maybe if I bought 5 games. Well, it says it says 4 points for every 1 game. So if you have 1 game getting you 4 points, 2 games would give you 8 points, 3 games would give you 12 points. I hope you're seeing what I'm doing here. I'm really only multiplying the X value by 4. Okay, and which makes sense because it says for every. the word for, or the phrase I should say, for every means multiply. I'm going to write that as a note at the top. For every means multiply. Now we talked about this before break as well. We said words like per meant multiply. For every also means multiply. Anything that you have a synonym for per, that would be the word multiply. So really, I just want to take that 5 that I put in my table and multiply it by 4. 5 times 4 is 20. So now I've got a few points in my table and I want to go ahead and graph this. Now the grid that I gave you guys doesn't have any values on it. That's because I want you to practice scaling your graph appropriately. So when I look at the points that I've created in my table, 0, 0, 1, 4, and 5, 20, I want to be able to at least reach all those points. I came up with them. I should at least show them in my graph. So I have 12 tick marks on my grid. So I want to be able to at least reach for the x's up to 5. Well, that's going to be easy. So I'm just going to count the x's by ones. And I'm also going to label my graph with the name that I gave it on the table. So this would be, the x-axis would be games, and the y-axis would be points. Okay, and I said I was going to label the x-axis by ones, and we should always start at 0. So here's 0 down in the corner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now for the y's, I need to be able to reach up to 20, and I only have 12 tick marks. So that I would actually want to count by 2's. So I'm going to, instead of labeling 1, 2, 3, 4, 5, and so on, I'm going to label 2, 4, 6, 8, and so on for every grid line. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Actually, you know what? I'm going to go back because I just thought, what if I keep in mind that second paragraph? That second paragraph says it wants to know if there's what the games would be in order to earn 48 points. So I'm actually going to want to reach 48 instead. I'm going to change my mind here, and I'm going to relabel the y-axis where it reaches 48 so that maybe if I continue the pattern that I see, I'll be able to figure out the answer just by looking at the graph rather than trying to figure it out in my head. So I want to reach 48 at the top. Well, I have 12 tick marks. 48 divided by 12 is 4. So that actually works out for earning 4 points for every one game. So I'm actually going to label these tick marks going up by 4's instead of by 1's or by 2's. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and 48. Okay, now I can actually start plotting. I'm going to make my pen a little bit bigger here. It's good to highlight your points to kind of make them into a big dot so that you can see and read where they are. But then if you put a line through them, you should know that anytime you draw a line, you're really just plotting more points. You're just not highlighting them like you highlight the ones from your table. So I'm first going to plot the points down from my table. First, no games get you no points. So 0, 0. Well, that's not big enough. Instead of 20, let's make it a 30. Okay, let's label that. Okay, and now one game would get you 4 points. So there's that one. And 5 games would get you 20 points. So there's that one. Now, if you notice, these 3 points look like they're forming a straight line. And you can put more points down than what you came up with in the table. Because really, you could buy 2 games and get 8 points. So let's plot that down. You could buy 3 games and get 12 points. 4 games and get 16 points. And I can continue this just by, as I said, that for every over there. We can keep multiplying. So if I want to plug in 6 games, 6 times 4 is 24. 7 games, 7 times 4 is 28. 8 times 4 is 32. 9 times 4 is 36. 10 times 4 is 40. 11 times 4 is 44. And 12 times 4 is 48. So there is the visual representation. Some of you may be asking, well, wait a minute, shouldn't I connect those dots? Technically, in this situation, we should not, because by drawing the line, you're saying that there are points in between the points that I've already plotted. However, can you buy half of a video game? No, you can't buy half of a video game. That'd be crazy. So you're not going to have in-betweens on this graph, so you should leave it as what this is called discrete. Okay? Other graphs where you connect the lines, those are called infinite graphs. So we're going to leave this one discrete because it doesn't make sense in the real-life situation for us to connect those dots. So now we've made our real-life representation of the example, our graph. Now I can actually answer that question. You need 48 points for a free game. How many video games do you need to buy to have enough points for a free game? If I look at where 48 points is, let me change my pen size here. Okay, if I look where 48 points is, right there, and I were to find the coordinate that is sitting across from 48 points, and I figure out what the x value is of that coordinate, that's going to give me how many games I have to buy to earn 48 points, which is 12 games. So now I would like you guys to try this. So this brings us to our main idea. If we look at the key idea here, there's actually 4 different ways that we can represent a situation. We have in words, what's going on. In fact, I'm going to highlight in this situation what words are actually being translated here. It says proportional relationships can be shown using tables, graphs, and equations. Each model below shows a proportional relationship where y is twice x. That's the situation here. Y being twice what x is. Well, if you look at the table that is supposed to represent the same thing, if you look at the values, 0 times 2 is 0. Well, that's what twice means. It means to multiply it by 2. So 0 times 2 is 0. If you continue this, you'll see that the table holds true for that sentence. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. So this table represents what those words did. Y is twice x. If we look at the graph, it would be the same thing as the table. If you examine all of the highlighted points, the ones that they bold and make into bigger bubbles, the point 0, 0, well, again, 0 times 2 is 0. And actually, you can compare it to the table. All the points that are highlighted are the ones that are in the table. 0, 0, 1, 2, 2, 4, and 3, 6. And we all know that those x values are twice to get to y. Which now we see in the equation. If you translate this, it says y is equal to 2 times x. 2 times x is really a synonym for twice x. And remember, the equation, or the equal sign, is the same thing as saying the word is. So this really is saying y is 2 times x, or y is twice x. It's a literal translation. So let's now take a look at another example. This time we're going to be dealing with percentages. It says a salesperson earns a 10% commission on sales of energy efficient appliances. Draw a graph to model the situation. Is the amount of the commission proportional to the amount of sales, and how do you know? Well, let's create the graph first, and then we'll talk about what it means to be proportional in math and looking at a graph. So in order to graph this situation, we're comparing the amount that you sell versus the amount that you earn in commission. So let's call, and not that let's call it, but it's labeled in the graph, sales is on the x-axis. So we're going to call the x sales. We're going to call the y commission. because you don't get any commission unless you sell something. So that would mean sales is independent and commission is dependent. You only get commission if you sell something. So it depends on the sales. So now let's start picking random values. It says we a salesperson works at an appliance store. So let's try to make it true to the situation. Appliances could cost hundreds of dollars. So let's start with if we buy no appliances, if we buy maybe a $50 appliance, maybe a $100 appliance, and let's go, I don't know, something a little bigger. Let's do like a $300 appliance. Let's see how much commission we would have made. Well, in order to figure out commission, let's see what mathematical operation we have to do. It says they earn 10% commission on sales of energy efficient appliances. Well, that means we're going to need to find 10% of what we sell. Let's actually write that down. 10% of what's sold. How do we translate into that into mathematical symbols? Well, 10%, if we were to move the decimal place, which is here, if we move it over twice, that's how we make it into a decimal. So this is 0.10. The word of means multiplication. So I'm going to translate that into a multiplication symbol. And then what's sold is X. So I'm going to say that this is 0.10 times X. So that's how I'm going to figure out what all the commission is. Well, I'm going to grab my calculator and I'm going to type in 0.10 times 0. Well, if I don't sell anything, I earn no commission. That makes sense. So no sales, no commission. Now I'm going to type in 0.10 times 50. 0.10 times 50 is 5. So if I sell $50 worth of stuff or appliances, I'm going to earn $5 because of that. Let's do 100. 0.10 times 100. That's going to be $10 of commission. And then 0.10 times 300, which is $30. So now I can actually graph this situation. And again, I need to scale my graph so that I can fit all of the points that are in my table. Now, there is no question on this one saying, you know, how much money do you have to sell in order to get a certain amount of commission? We just have to answer if it's proportional. So I'm not looking for any specific values, but I do want to fit all the values that I have in my table onto the graph. So I want my X's to be able to reach 300. If we count the grid lines here, there are only 10 of them. So I'm going to scale my X's by 30s. Because in order to get to 300, if I were to scale by 30s, then I get all the way up to 300 at the last tick mark. So 0, 30, 60, 90, and actually I can already tell if I keep going 120, 150, it's going to get really, really cluttered. Like I'm going to have a really hard time reading the numbers. So I'm going to go back. And I'm going to maybe spread them out a little bit. So if I call this one 0, maybe I won't label the 30. I'll just label the 60. And that's okay. You can skip some of the labels if it helps you clean up the numbers. So 30, 60, 90, 120, 150, 180, 210, 240, 270, and 300. So it's a little cleaner. And on the Y's, those were a little smaller. My commission was only 10%, so I only really need to reach up to 30 on the Y's. So instead of scaling by 30s, I'm going to scale by 3s. You could do the same thing here if you want to skip a grid line. So the first one would be 3, the second one would be 6, 9, then 12, 15, then 18, 21, then 24, 27, then 30. So now I'm ready to actually plot. I'm going to get my pen to be a little bit bigger so that when I plot my points, they're highlighted. So 0 sales would mean 0 commission. There's that point. The first one that I did was $50, which again, you can estimate where 50 is. I scaled my graph by 30s. So I kind of have to estimate where 50 is on the x-axis. It's not quite 60, it's a little bit below. So I'm going to put it between the first and second tick mark, a little bit closer to the second one. And then I'm going to go up to where I would do the same thing for 5. So I'm 50 and then 5. I would say that's right about there. My point's too big. Let's try another one. Right about there. So now I want to plot 100. Well, 100 is in between the 60 and 120, and it definitely is more towards the 120. And it's going to be in between actually 90 and 120 and more towards the 90. So this line right here, it's going to be more towards that one than the 120. So I'm going to estimate that 110 are about right there. And then my last one in my table, is my last one? No, yes, okay, so I want to plot 330. So 300 is all the way at the end, 30 is all the way at the end. There's that point right there. So you can tell that they're all falling in a straight line. However, do I have to continue to think about all the different situations and plot lots more points? No, because in this situation, unlike the first example, it makes sense for all kinds of numbers. You can sell $50 worth of appliances. You can sell $51 worth of appliances. You can sell 50 cents worth of appliances. So because there are an infinite amount of possibilities here for us to plot, we're going to take these 4 points and we're just going to connect them into a straight line. And that's actually how we're going to answer the second question. The second question here says, is the amount of commission proportional to the amount of sales, and how do you know? We can say yes, these are proportional. The sales is proportional to the commission for 2 reasons. When you look at the graph passes through 0, 0. That's really important. That has to happen in order for something to be proportional. Secondly, it has to form a straight line. If you see that the points that you're plotting are creating a perfectly straight line, then it must be proportional, which makes sense because you are multiplying everything by that 10%. So it should always be the same proportion that you're getting from each sales to get your commission. All right, so I've got one last example here for you guys to look at. It says ice forms at 0 degrees Celsius. The surface temperature of the ice on an ice rink decreases 0.5 degrees Celsius every hour. Draw a graph to model this situation. Start when the surface temperature of the ice is 0 degrees Celsius. Is the surface temperature of the ice proportional to time? How do you know? Okay, so that second question, again, we're going to look for if when we draw the graph, does it form a straight line and does it go through 0, 0? Well, that means we have to do a little bit of interpreting of this top paragraph because there's a lot of stuff going on in that top paragraph. So let's start by what I read that struck important was that we need to start when the surface temperature of the ice is 0 degrees. That's kind of important because it's not that we're looking at it from when the surface temperature is 20 degrees Celsius. We're looking at it when it starts at 0. And if you look at the way the graph is, that's why we're in the 4th quadrant. If you take a look, if I were to actually draw the rest of the quadrants of this graph, the first quadrant would be over here, second quadrant would be over here, third would be over here, and the fourth would be over here. Usually we've been graphing in the first quadrant because that's the positive quadrant. When x is positive, when y is positive. Okay, but in this case, we're starting at 0 and we're decreasing. I'm going to highlight that. It says decreasing right here by 0.5 degrees Celsius every hour. So it's starting at 0 and it's going downwards. So that's why y is in the negative right now and x is in the positive. So I'm going to create a table of values to represent this situation where x is my surface temperature, or excuse me, where x is my time in in hours, I should say, and my y is my surface temperature. So starting at 0, let's start at 0 in our table too. So if we start at 0, that means no time has gone by. So the temperature should not have dropped. So it starts at 0. At start time 0, temperature starts at 0. But what if an hour goes by? What if 5 hours go by? What if 10 hours go by? What would the surface temperature be then? Well, it's going to keep decreasing by 0.5 degrees Celsius every hour. So if 1 hour goes by, it should be negative 0.5 degrees Celsius because that's a drop of 0.5 degrees. Well, I don't want to have to keep just subtracting 0.5. So we can do the same thing that we did in the other examples because it says for every hour. Okay, for every, per, that means multiply. So we want to multiply the 5 by negative 0.5. So I'm going to grab my calculator. I'm going to type in 5 times negative 0.5, and that gives me negative 2.5. I'm going to do the same thing for 10. 10 times negative 0.5, which gets me negative 5. And now I'm ready to graph what I've come up with in my table. And again, I need to think critically about how I'm supposed to scale. In this graph, I'm counting 10 tick marks, 10 grid lines. So on the x's, I can count by 1 because my table, I only really made it up to 10 anyway. So I'm going to scale my x-axis by 1s. 0. Oop, my pen's a little too big. Let me make it smaller. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But I do want to be able to reach negative 5 on the y. Now, negative 5 is, I can spread that out a little bit. Negative 5 is less than negative 10. So if I only want to reach up to negative 5, I can spread it out a little more over 10 tick marks. So instead of labeling each grid line, I'm only going to label every other by 1. So if I start at 0 and I skip a grid line and I go to the second grid line, I'm going to call that one negative 1. Skip another grid line and go to the next one, that's negative 2. So I'm just counting by 1s downwards, but I'm skipping a grid line every time just to space it out a little bit so that I can use the entire graph and all the points are nice and spaced out and we can read them very, very easily. So now I'm going to start plotting. Well, again, we start at 0, so when no time goes by, it's at 0 degrees Celsius. If 1 hour goes by, we're at negative 0.5. That's right there. 1, negative 0.5. Now we started to jump. Well, what if 5 hours went by? That was negative 2.5. So I'm going to go down to 2 and then halfway in between negative 2 and negative 3, right there. And then my last point that I came up with, 10, negative 5. That's right there. And again, this is one of those situations where in-betweens make total sense. So I don't want to just leave it as dots. I want to connect those dots into a straight line. You don't need to be perfect, okay? You can see my imperfection in my straight line, okay? But you want to make it as straight as possible. If you need to, use a ruler. And you also want to make sure you put that arrowhead on the end, showing that it does go on forever doing the same pattern. So now that we've created our graph, we've analyzed it, we can actually answer that second question in the example when it says, is the surface temperature of the ice proportional to time, and how do you know? I would say this is absolutely proportional. The surface temperature is proportional to time because it's forming a straight line and it goes through 0, 0. As well as, if you want to go back to our original reason, was we're multiplying it by negative 0.5 every time. So it's going to have that same proportion if you multiply something. So this definitely is proportional. Let's have you guys give your third U try a try.